I'm here to tell you that ohmage don't matter. The reason is that ohmage isn't a real word. It's sort of made up one by taking the word ohms and sticking an idge on it to actually talk about impedance. And impedance is a more complicated form of resistance where we have DC resistance plus inductive reactance and capacitive reactance. Is it capacitive or capacitive? Anyway, let's not get too deep into this, but let me show you one thing. You will see that a speaker cabinet is given an impedance number, like say 4 or 8, yeah? Or 12 in the case of one of ours, or 16 with some guitar cabs. And if you were to plot that on a graph, so if this is impedance in ohms up here, and this is frequency in hertz, that would tell you, wouldn't it, that a 4 ohm cab should be like that. It's not. It really isn't. It'll be something like this, or something like this, or a variant upon that. So that line for 4 ohms won't be the bottom of it. It certainly won't be anywhere near the top. I mean, it really won't be anywhere near the top. It might be a 10th of the highest point. It might be a 20th. It's a lot lower. It's in a seemingly random place, and I shall get into that in a subsequent video. But for now, armed as I am with a total lack of whiteboard rubber, should have thought of that, I just want to get into the sort of impedance 101, as the Americans say. I think that means the simple stuff. I read an interview a long time ago with the Metallica bassist Jason Newsted. He talked about writing songs that were just like Metal 101 versus Hetfield's writing, and I had no idea what he meant, but I think 101 is meant to mean simple stuff. If there are any Americans out there who could enlighten me as to why that is, I would like to know. So we have two sorts of amplifier we use. We use solid state amps, or we use valve amps, also known as tube amps. And there is a massive difference between how these two sorts of amplifiers work. And today, I'm going to briefly touch on valve and tube amps and then move on, and we'll just focus on solid state ones, because valve tube amps, it's a lot more complicated what's going on, because you have an output transformer and you're dealing with valves that, basically valves don't on their own want to drive speakers. The sort of things that valves do does not match up with what speakers want, hence the output transformer, and that adds another level of complication. But suffice to say that a valve amp has output taps. So say you've got 2 or 4 or 8 or 16 ohm taps, I'll stand on the other side, on your valve amp. That will be happy driving 1 to 4 ohms. That will be happy driving 2 to 8. That one 4 to 16. That one 8 to 32. And when I say these numbers, 1 to 4 ohms, 2 to 8, 4 to 16, 8 to 32, that's the nominal impedance thing. So again, this is what the speaker's actually doing, and this is saying, and this is the nominal line for that speaker. So say that's a 4 ohm speaker, for instance. What we're actually saying is this 2 ohm tap is going to be happy driving a speaker that is nominally 4 ohms, but actually goes lower and goes higher, and there's phase as well involved. But that's the thing to remember with valve amps and their output transformers and the taps. They're doing an approximate job of matching the nominal impedance. It's all very approximate. It works. What valve amps don't like doing is driving an empty load, because you have this situation where the amp is putting out power into one coil of the transformer, so power's going around there, and then you've got this other coil of the transformer, and that would generate power which will then come out to your speaker here. Problem is, with a solid state amp, if it's trying to put out power here and there's nothing connected, there's just a dead stop. You know, the electricity can't get out, no current flows. But on a valve amp, if there's nothing connected here, current can still flow round one side of the output transformer, so it just goes round in this terrible loop, and this bit gets really upset, and bad things happen to transformers if you drive them with nothing connected. While solid state amps, if you don't connect anything, no current flows, no problem. So that's the brief bit on valve amps, which was actually not as brief as I was planning. So solid state amps. Oh, another aside, does anyone know if you can refresh whiteboards? I mean, obviously we can clean them, but can you like spray them and polish them and re-lacquer them? Because this is a magnetic one, so I don't really want to replace it with a generic bit of wood, because it's used to be able to stick things to it, but conversely, it would be nice to have a sort of shiny white thing. Maybe I could get a matte one. Maybe you could do matte with a clear lacquer. Who knows? Tell me if you know. So a typical amp, maybe say 500 watts amp, yeah? And when they say 500 watts, that will usually be the power at its minimum load or around its minimum load. So it's usually 500 watts at 4 ohm impedance, not ohmage. And an amp like that will usually produce 300 watts or thereabouts at 8 ohms. What's happening is we are doubling the impedance, so we're halving the amount of current that can flow. So you would expect it to actually half the power. The reason it doesn't half the power is not because it doesn't half the power, it's actually the other way around. It doesn't manage to double the power. So really, 300 should get us 600 watts once you halve the impedance. But the amp goes from being limited by voltage or by a mix of voltage and current to being current limited. So basically it can't keep doubling its power as the impedance decreases. So if an amp is rated at 500 watts into 4 ohms, 300 watts into 8 ohms, it will then into a 12 ohm load. It'll probably do about 200 watts at 12 ohm, and it'll probably do 150 watts at 16 ohm, and so on. And you can go higher and higher and higher with the impedance. If you get some studio headphones, they are very high impedance. Are they 600 ohm? So if you put a 600 ohms, I think you can actually run a set of 600 ohm headphones off a normal power amp, and because the impedance is so high, so little current flows, that it turns the power down so much that you could run headphones, probably, I'm not sure on this, I'd need to check, off the actual power amp that can normally drive a speaker with hundreds of watts. Don't test that and blow your headphones up or go deaf without checking first. But that's what I'm trying to say to you, that your solid state amp can run from a minimum impedance up to an infinitely high impedance, and it doesn't care about those infinitely high impedances. And the reason it doesn't care about infinitely high impedances is because the higher the impedance, the less the current flows, so the less work the output transistors do, and it becomes eventually like not having anything connected. And they don't mind having nothing connected. The volts go up and down, but no amps happen, so no power flows. So it all works out quite happily. So that's kind of your basics. Now there will be a minimum impedance, and that minimum impedance really is determined by how much heat the transistors can deal with, how much they can get rid of. So the more current flows, the more heat comes out of the transistors, so the greater the loss. So the limitation then becomes how much current can travel through the transistor without other problems happening. I mean, this gets into really deep electrical engineering. I don't want to get into that, but what I want to do is try to explain a bit more about what's going on with impedance. So that's looking at it from an amp perspective. I think I'll stop there because I'd like to know what you think and what makes sense to you about this, and then we can start looking at adding extra cabs, series wiring, parallel wiring, and into the valve amp thing, and yeah, the other stuff. It's a big topic, and I think we need to do it in little bits. So I shall stop now and say to you, yes, impedance does matter, but don't overthink it. If you're confused about it, email me. If you're a customer, I'm very happy to help. If you're not a customer, I'll help you, because one day you might be a customer, or you might make a friend of yours or someone else a customer, because we do good things and we try and make the world a better place, and hopefully that will mean people buy our stuff and we can keep doing what we do and continuing to make the world a better and better sounding place. So thank you. I've been Alex from Barefaced. Impedance, don't be scared of it. It's okay, but if you are scared, talk to us, we can help.